in section 2.2. And we're going to move that into section 2.3. And I have made note of where in 2.3 I need to be by the end of the lecture. So we're going to move through the stuff. On this one, very quickly, though, to finish up section 2.2, use the graph to identify the values of C. Now, when we say the values of C, let's just do a little bit of review here. When we say the values of C, what are we talking about, input or output? We have to know that. We have to know what C represents, and you're right, this is input. Okay, the values of C, input values. Now, that input value is, remember, that's where we're taking the input. We're going to move the input closer and closer, the input variable value, closer and closer to this value C. So identify the values of C for which the limit, as x approaches C, f of x exists. Now, when we talk about this notation, this is your review from last week. When we talk about this, what are we thinking of this? This is representing what part of the function? The output values. Okay, so we're saying that as we move the input values closer and closer to that destination, that value C, we want to know for which input values of C does the limit of the outputs exist? Is there a limit? So we're going to move the inputs and we want to know what happens to the outputs. Are they going anywhere in particular? We want to know, does that limit exist? Okay, so we take a look at this little diagram here. Obviously, some things are going on in this function. I don't have an analytical explanation for, I can't say f of x equals, for instance, but we can see the graph of it. And we want to know for which values of C does the limit exist. Now, sometimes, a lot of times in mathematics, it's easier to ask the opposite question. For which values of C does the limit not exist? Okay, so we're going to go with that. If we can say which ones it does not exist for, then everything else, it does exist. So if you look at this, we obviously have something happening here at 4, something unusual happening here at 4. We have something happening here at -2, and something happening here at 0. Okay, why do we think those are special? Well, because there's some breaks in the graph. They're not continuous. We're going to talk about continuity in section 2.4, but they're not continuous. So let's take a look at the limit as x approaches, let's try -4 of f of x. Now, when we write this notation, remember we have these things called one-sided limits. Remember those? Because this is the whole premise of having a limit. It means that if I come up from the less than -4 side, and if I to -4, and if I come up to -4 on the greater than -4 side, again, my question is, what's happening to the outputs? So as I come up to -4 on the less than -4 side, where are the outputs going? To +2, aren't they? +2. If I come up from the less than -4 side, where are the outputs going? To +2 also. So is there a limit as we approach -4 from both sides? Yeah, it happens to be 2. Now here's something that's kind of previewing that section on continuity. What is f of -4? It's 0. Not the same thing, is it? Hang on to that thought for section 2.5, okay? We're not going to talk about it here today, but hang on to it then. Okay, so the limit does exist through -4. Well, the other place that we have a problem with is right here with -2. So let's look at this. The limit as the inputs approach -2. What's happening to the outputs? Well, as I come up to -2 from the less than -2 side, where are the outputs going? -infinity. That right there tells you what? The limit does not exist. Yeah, the limit does not exist. As I come up to -2 on the greater than -2 side, they're also going to -infinity. So what do I write here? Yeah, I'm going to write does not exist. And then what do I have to put down here? Yeah, the reason it does not exist is because it's going to negative infinity. Okay, outputs are going to negative infinity. Okay, so we know now a place where the limit does not exist. By the way, is there an f of negative 2 value? What's that dot mean? Yeah, it's kind of stuck right there. It does have a value, okay? So again, this is a little preview, and this is a little preview of section 2.5. Just kind of hang on to those. Don't think about too much now, but we're going to be working with that in 2.5. Okay, so here we know that the limit does not exist. Well, the other place is right around 0. So we've got the limit as x approaches 0. What's happening to the outputs? As I come up to 0 from the less than 0 side, where are the outputs going? 0. So I come up to 0 on the greater than 0 side, where are the outputs going? 5. What do you think? Does not exist. Now we have to give it a reason. Yeah, don't clap. The more mathematical phrase for that is we have two different one-sided limits. Yep, one-sided limits. Okay, so now we have two places where the limit does not exist. Any place else? Well, are we ready for the conclusion? The limit as x approaches c of f of x exists for what? What values of c? Ooh, just negative 4? Yeah, because what if I say, well, what's the limit as x approaches 5? Does the limit exist there? Yeah. What about if I change that to negative 5? Does the limit exist there? How about 1/2? How about pi divided by 3? How about, okay? So actually the limit exists everywhere. So for all c not equal to negative 4 or negative, oops, I said it wrong. Said it wrong. Help me out here. Except negative 2 or what? 0. There we go. So that is our answer to this problem. Okay? A little reminder, a little review of what we did last week. Limits come up from both sides. And we have to be able to clap. We have to be able to give a reason if they don't exist. Okay. We're looking at moving the input values closer and closer to some destination and then asking ourselves what's happening to the outputs. These are all the concepts, the ideas I want you to carry with us, carry with you. Okay, let's go on. This one is one of those that I love to ask, hint, hint, hint. And what I want you to do is, take it on your paper there, I want you to draw a function that has all of those, one function that has all of those characteristics. Okay, you're being recorded there. Excellent. You did a great job. Wow. Thank you much. Okay. Little applause for her. First person up here. Okay. Does it go by what we say? Is f of negative 2 0? Yep. There it is. Negative 2. Is f of 2 0? Oh, there's our 2. Does the limit as x approach negative 2? Now, the only thing I would change on yours is we have to go from both directions. So, whoops, in front of it here. Yeah, we'll just have that extend up there. So we can say we come in from both directions, okay? And the limit at f of 2, or at 2 does not exist because two different one-sided limits. Okay. Now there's another way you could draw this. Anyone have a different way you volunteer to share with us? You can see this not hard, is it? Man, we got a storm raging out there. Okay, so I said you have something to show. Okay. Aren't you glad? Oh my goodness, the wind's blowing across that parking lot. Aren't you glad you're not out there? Oh. Okay. Okay. We'll just pick up the eraser here. Okay, we'll try this one more time. I just like it with a pencil. Oh. So bring it over to the, there you go, and then place it down. All kinds of things happening today, okay. Coordination for this. That's okay. That's okay. It does take a little bit. Let me get us started here. I'll drop it. Okay. So we've got -2 and 2. And you've got, this is coming down here. Is that right? Okay. Is it connecting or is it just going down? And then it's coming, and then it's coming on this side up to 2, and then up here like this. Is that correct? Yeah. Okay. One thing I would change on this. What would you change? Anyone? Well, let's see here. F of -2 is 0. Check. F of 2, we'd have to make that, and then have to make that an open circle, and you had that, I didn't put that in. As we approach -2, I don't think I would change anything. Except that circle. Okay, so a couple of ways. Now again, we have two different one-sided limits here. What we could do would be to come over here at 2 and have something like this. Whoops. Something like that. Okay, well, we had some limits of that nature. We don't like that, so we're going to erase mine. Whoops. Okay. Again, keep this in mind as an example of one that I really enjoy putting on a quiz or a test, because it gets us into a thinking mode that's not just moving some numbers around or having to memorize anything. You have to show me what you understand. And that's always going to be the important thing. Showing me what you understand, not how much you can memorize. Okay. So let's go into section 2.3. Thank you. I did forget to look at that. So we will stop this and start.